Hello everyone, I am Jubeda. He is my teammate Manikanta. Our mentor is Mr. Akshay Kumar. Today I am going to explain a problem called contains duplicate 2. This is the problem about arrays and duplicate values. Here we also check how close the duplicate values are. We are given an array called nums and a number k. We need to check two things. First, the values must be the same. Second, the index difference must be lesser than or equal to k. If both are true, we return true. Otherwise, we return false. This means both elements must have the same value. We calculate the distance using the I minus j. This distance should be within k. If both conditions match, we return true. If not, we return false. An array stores elements in order, index from 0. We know that. Duplicates elements are values that appear more than once. Index distance shows how far two values are in the array. K limits this distance. There are so many ways to solve this problem. One simple way is the brute force approach. I am explaining this approach here. In brute force, I am comparing each element with all other elements. I use two loops. One loop picks the first element. The second loop checks the next elements, right? Time complexity is big O of n square because of two loops. Space complexity is big O of 1 because of no extra space is used. This method is so easy but so slow for large arrays when it comes. This is the brute force code in Python. First loop selects one element, second loop compares it with others. If values are equal and index distance with in k, we return true. If nothing matches, we return false. Here, value 1 appears 2 times. Index is within k. Okay. So, duplicate is found. We return true. Here duplicate exists but index difference must greater than k is greater than k. So no value duplicate is found. We return simply false. Duplicate values, index values we check in this problem. Brute force is very easy to understand but it is very slow for big inputs for large arrays. Thank you.
Hello guys, so far we have seen the brute force approach for solving content duplicates problem. Although method is easy to understand, it becomes insufficient for large inputs because it's using nested loops. Okay, to overcome this problem, we move to more efficient solution. This is known as a optimal hash map approach. Okay, let's see this slide. Uh, Optimal hash map approach contains a time complexity is O of n and space complexity is also O of n. It means only in time complexity only we use the one for loop and time complexity and space complexity we use the only one variable like hash map, so it's contain n. And now in this approach we solve the problem in a linear time. Okay, instead of comparing every pair of elements, we store the last index of the each element while traversing the array once. Okay, whenever an element appear again, we immediately check the difference between the current index and the previous index. Okay, if difference is less than or equal to k, we return true. Other than we return false. It means uh, it does not equal to k. We return false. Okay. Mm, let's see the optimal approach of the code. Okay, we create the hash map and it is a for loop to iterate the each element in the array. Okay, uh, in this index map num I equals to I is inside the for loop. It is my bad, it's ppt problem. Okay, and in for loop this condition in array of index 1 in contain in hash map, and also it contains high minus in index of map less than equal to k, it returns true. It not returns true, it other than false. Okay. Mm, now let's see one example, you better understanding it gives you. Okay, in this example we see 1 2 3 4 1. Okay. mm, when the element 1 appears again at the index 4, the hash map already contain 1 at index 1, index 0. The index difference is minus or 4 minus 0, which is equal to 0. So since the value is less than or equal to k, so it's found a duplicate is found. It returns the true value. Okay. And another case was no duplicate found. It means in this case we let assume 1 2 3 4, there is no one. Okay. Mm, okay. Although the element repeats the index, difference is greater than k. Like here you see difference is greater than k. Like in previous case we use the less than k. It gives the duplicates. Greater than k, it gives the no duplicate forms. Okay. Okay. From this comparison table, we can clearly see that brute force approach is simple but inefficient due to we give a large amount of input. It's iterate for loop two times, like for in nested for loops. So it gives time complexity is n square, and also space complexity is also O of n. And compared to optimal approach, in approach we used only one for loop. It contains the time complexity is O of n, and space complexity is O of n. So here you can see this brute force and hash map. So simple to implement is brute force, but large of amount of input we given, it became too slow, or large inputs doesn't support. In hash maps we give a large amount of array or anything, it efficient to these content duplicates are exist or not, requires extra memory. Okay. Mm, the hash map approach, although uses extra space, is much faster and suitable for large inputs. Okay. Mm, these are the additional examples. Once you dry run it, and you understand the what is the content duplicate problem. Okay. um, Now I'm conclude that the brute force approach helps us to understand the problem, but it not practically for large input size. Okay. The optimal map approach is efficient for scalable and preferred is real world applications. Okay. Thank you.